Welcome back, people. This will be part 4 of our Frogger mini-series, and in this video, I'm going to show you how to set up animation blueprints inside Unreal Engine. This will be a quick and easy tutorial to follow, and although the setup will be specific to our Frogger prototype, you'll be able to take the information here and apply it to any project you're working on. Let's go ahead and jump right into it. Alright, so let's go ahead and create a new folder. So we'll right-click, select New Folder, and we're going to call this one our Anim, short for animation folder. We'll double click and go into it, and what we're going to do is right click, select animation, and then we're going to choose animation blueprint. It's then going to have us choose a skeletal mesh. For this example, we're obviously going to use the frog skeleton, and if you just need a quick overview on how kind of these systems work, if you're inside Blender or Maya or whatever 3D modeling software you're using, typically you'll create what's called a static mesh, which is the model itself. And if you want to add any animations to it, what you'll do is you'll create a rig, which is basically a skeletal mesh that you'll put inside the static mesh, and then you'll basically parent it to the mesh, and you'll assign kind of like weight points so that the various bones, when they're rotated or manipulated, they'll actually deform the mesh, and that's actually how we create the animations. So when we're setting up animation blueprints, it of course, all that data lives on the skeletal mesh and not the actual static mesh. So that is to say, we're basically going to select the frog skeleton. We'll hit create and we'll give it a name. We'll do ABP underscore Frogger. And we can just double click to open that up. And it brings us into the anim graph. And at the top, you also have a tab for the event graph. This is pretty much where you'll code your logic. You can like set up variables, give them values, different things like that. And you can use all that information in the anim graph to change the animation state. Imagine going from like an idle to a walk to a run to a jump, that sort of thing. But to start off, let's go into the event graph and let's actually create some of the logic here. I think for this project, we'll create 2 variables. The first one we can call speed, and speed is going to be a float. And then the second variable we'll do is maybe is airborne, and this one will actually be a boolean. All right, with that done, we'll set the speed variable first. So we'll hold Alt, drag it in. And to be able to set the speed, what we can do is on the try get pawn owner, we can pull off into a function called get movement component. What this function does is it allows us to get the script that's attached to the character blueprint. And there's a movement script on there. So, and that has a bunch of information that we can use to basically populate things like speed, rotation, velocities, what have you. So we can basically pull off this and get what's called, there's a velocity variable that's attached to the script. And then we can use that and get the vector length. And that vector length we can simply populate into our speed value. Now to get the airborne value, basically the true, false, yes, no of the is airborne, what we can do is off the character script on the movement component, we can get the function is falling. And that'll just return true, false on if the character actually had jumped. And then we can just select our is airborne. If I just drag it out, it lets you choose a getter or a setter. In this case, we want a setter. And then we'll just simply pass this boolean like so. And then we can compile and save. And this is just basically driving the logic of the animation blueprint to populate some variables that we can use creatively in the anim graph to switch between various animation states. So let's go ahead and show you what that looks like. So we'll go to the anim graph, we'll create a new state machine. And then I'm just going to simply call this locomotion. We can pass this in to the result, hit compile, and then we just double click on locomotion and we're in kind of our various state machines. So you can add as many as you want. For this one, I'm just going to do 3 simple states. So I'll pull off, click add state. I'll have a simple idle state. And then from my idle state, I want to be able to go into like a jump or a hop state. So we'll do add state and I'll call it jump. It's probably a bad name. Maybe I should call that hop, but we'll make it work. And then I'll add another state and we'll call this one maybe falling. Now I want to be able to move from an idle to a falling, and then a falling back to an idle, and I want to be able to go from idle to jump back to idle, and then I want to go from jump to falling and falling back to jump. So I want to be able to dynamically switch between these states, and you can see the arrow represents a pathway for one state to lead into another. So if you want your states to be able to transition to one another, you'll not only need to create pathways there, but you'll want to create pathways going back if the animation state should have that ability. Now, not all animations should, but it's going to be very dependent on the project you're setting up, of course. But I think for this example, we'll set it up this way just to kind of give you an idea of what's going on. Now, these little icons here are your logic for the transition states, and these little pins on the end represent the actual animation state. So let's go into idle first, and then you can kind of see what this looks like. I think what I'll do is this static mesh has a few different idle states. You can use whatever one you fancy. I'm going to use idle 3, populate it in here, hit compile, and you can see our little Frogger is animating. Now when the animation reaches the end of the state, you'll notice it stops and it does not repeat. The details panel on the right will give you various options with the animation, and you can of course double click on the animation itself and make basically global settings adjustments. So like you can force it to loop and change the play rates and do all sorts of things in here. We're going to keep it simple though, and we're just going to stay inside the animation blueprint. So I want to loop this animation, so I'm just going to check this little box and hit compile, and that way it'll just basically go on repeat until something else happens. And if we go back into the locomotion graph, you'll notice that our entry pin drives right into idle. So idle is able to be hit right away. That's why I don't have to set up any logic to actually go into here. But if we want to move into a jump or it is falling, we have to set up these various pins to make that work. So let's do that. So in the jump, I only have one jump animation, so I'll drag that out here, hook it up like so. And for the jump, this is going to be, it's kind of misleading. I probably shouldn't name the jump, but this is like when the little Frogger is hopping along the road, so it's going to repeat quite a bit. So what we'll want to do is we'll want to check loop animation for that as well. And then the last one, if we go back here, is the is falling. This one's a little tricky. We're going to use the jump animation again. But what we're going to do is we are going to set the play rate to be 0. And we do that so it doesn't actually play through the animation. But instead, I'm going to set the start position to be 0.5, which represents half of the animation. So it's going to go to the halfway point because it's a value between 0 and 1. And the halfway point, basically the frog is, kind of mid-jump. So we'll basically freeze frame the frog mid-jump, and then when the animation, or when the state is finished and it goes back to an idle or a moving, it'll flip back to the other animation states. Now this one will not have a loop because we're basically freezing the play rate. So that's pretty much good there. So now we've set up our various animations. We just need to set up the actual states going between them. So for the first one, the idle to jump, we can double click. And this one, we're going to use our speed variable. So I can drag out speed and do a getter. And then we can simply check maybe if speed is greater than maybe 1. Then we'll say it can move into the movement state, or in this case, we named it jump. So we'll compile, and that one is good. But we need a way to control going back. So we can double click. We can get the speed variable again. This one we can say, is this less equal to? And then we can also say 1. So basically, if it's 1 or less, basically 1 or 0, then it's basically going to be in an idle state. So we'll move that here. And if it's greater than 1, then we're actually going to transition into a movement state, or a jumping or hopping state. Now for the jump to falling, that state, we can just simply open this up here, and we'll just do is airborne right into this check. And that'll work perfectly fine for that. But for the falling going back to the jumping, well, that one we need to say is airborne not true. So we want the inverse. So we'll do a not Boolean. And then we'll just pass this in like that. And this logic is actually identical from the falling to idle state, right? So from idle to falling, that one is just simply is airborne. And you can pay attention to these little warnings at the bottom where it's saying falling to idle will never be taken. Again, if we go from falling to idle, that's this little pin here. That's going to be the same as before. We'll do a getter. We'll say not Boolean to get the inverse. Pass it in here, and then this little warning will go away when I hit compile, letting you know that your animation blueprint is good. It's basically checking. It's like, okay, we got 3 different animation states. You know, did this coder actually set up a way for us to go between each of the various states? So it's a good thing to pay attention to see if you messed anything up. But yeah, so that is, in a nutshell, the animation blueprint. It's very simple. Now what we can do is, if we go to level, nothing's going to work, right? We're still stuck with, you know, our kind of bland movement style here. But if we open up our blueprint, and then we double click our player blueprint, because this is the character class blueprint, we can simply, it comes with the character mesh, and the character mesh has a animation slot already built into it. So I can just hit the drop down and select the animation blueprint for the Frogger that we just created. And when I do that, you can see that the Frogger is animating. It looks good. He's idling well. He's obviously not jumping or falling, so he's not in a falling state. He's not moving, so he's not in a hopping or jumping state either for that. So if we go back into our level, we can see he's a little bit more lively, and we only used a single idle animation. I did include a few of them on there. You can actually set up a structure, a way where it'll cycle between, you know, the various idle animations randomly or in some sequence if that's something you'd like. And then when we move around, we can see we are now hopping around in the various directions that we move. So now remember, we're only moving in 4 cardinal directions, and we're not actually rotating the capsule component, which is the root of this player blueprint. We're simply rotating the static mesh, so it gives the illusion to the player like we're actually rotating. And then if I jump, you know, that's moving just well. And I can hop around like so. Now the play rate seems a little bit slow. You can adjust that a few different ways. I'll keep you inside the animation blueprint to keep it simple. But basically on the jump, we select the little jump animation we're using, and then we can maybe bump the play rate to something higher. So maybe 1.5, compile. And if we play, maybe that looks a little bit more correct. It looks a little bit better and a little bit more livelier. One other thing I think would help the project out a little bit is to add a little bit of camera lag. We can go back into our player blueprint, select our spring arm, and there is a lag section. You just check the little box here to enable the camera lag. Camera lag speed, the lower value you use, the more lag you introduce. And I just find it gives your projects a little bit more visual oomph, I guess. Alright everyone, that's a wrap on this video, but in the next one, we'll create the vehicle obstacles that our player will have to avoid in the final product. As always, thanks for watching, consider subscribing, and we'll see you on the next one.